In the previous lesson, we talked about perimeter and area of basic shapes. In this lesson, we're going to talk about perimeter and area of composite shapes. So what are composite shapes? So basic definition I've written down here is a shape. Composite shape is a shape that is composed by two or more basic shapes. Okay, so we know what the basic shapes are because that's what we studied earlier in the previous lesson, like a circle, rectangle, square, trapezoid, all that stuff. So if you look at the first example, this is a composite shape. I have a triangle attached to a rectangle. If you put them together, you have your composite shape. For example 2, you have a semicircle and a rectangle. So you put those two basic shapes together and you've created your composite shape. The last example, we're putting a triangle with a rectangle with a square. You put those three basic shapes together and that forms our composite shape. So let's try example 1. But I do want to mention that what we're doing is exactly the same as what we did before. We're still talking about perimeter. That definition has not changed. We're still talking about area. That definition has not changed. It's just that the shapes themselves have changed a little. But as long as you are very comfortable working with the basic shapes, then composite shapes shouldn't be too bad. Before I talk about example 1, I just want to add some markings to the first diagram here. So we have right angles here, okay? We should never really assume that these angles are right angles. So these angles are right angles and these side lengths are the same. So I did add these markings here. And I want to mention that this figure reminds me of a house. So I'm going to refer to this composite shape as a house. So this, to me, the triangle looks like the roof of the house. And let's say the rectangle is, I don't know, let's say it's the garage. Okay, so I know this might be obvious to you, but I'm going to say it anyways. Is this measurement here, because it's a rectangle, this measurement is 3.5 meters. Okay, and if our job is to find the perimeter of this composite shape, we really want to know the measurement of these two lengths, which are the same. Because once I know these two values, then I can solve for the perimeter. But right now I cannot solve for the perimeter. So I'm desperately looking for a way to solve for this measurement. Okay, let's see. So how can I solve for this? You know what? I think I have a plan. Let's chop this triangle. Let's chop this isosceles triangle in two. So I'm going to draw the triangle. Okay, I'm going to call this X. So this will be X. Okay, what is the height of this triangle? What is the base of the triangle? So let's talk about the height. What is this? Well, the height of the whole house is 5 meters and the height of the garage is 3.5 meters. Then the height of the roof, hopefully you can say, is 5 minus 3.5, which is 1.5 meters. So the height of this triangle is 1.5 meters. What about the base though? What about the base of this triangle? Well, if the whole thing is 6, if the garage is 6 meters wide, then half of that would be 3 meters. And what do we have here? We have a right triangle, and we can solve for that hypotenuse using the Pythagorean theorem. So 3 squared plus 1.5 squared equals x squared. So this is going to be 9. This is 2.25 equals x squared. X squared equals 11.25. Square root both sides. So x is the square root of 11.25. I'm not really interested in that value. You can approximate it, but I'm not very interested because I'm going to use this. I want to keep this as perfect as possible until I perform the last calculation to find the final answer. So you know what? Like I said earlier, once I solve for this measurement, then I can solve for the perimeter of this composite shape. So P is equal to 3.5. I'm going to start right here, 3.5, and then walk around. So plus 6 plus 3.5 plus x. Bam. Walked all around the composite shape. Please, please, please never include this measurement. Tons of students include this measurement as a part of their perimeter calculation. This is not part of our perimeter because this is not on the outside of the shape. Remember we talked about perimeter in the previous lesson? So please, this has nothing to do with our perimeter. So add an extra 6 to this value here. Okay, so you could do 3.5 plus 3.5 is 7. 7 plus 6 is 13. I'm going to let x equals root 11.25 plus root of 11.25. You know what? The calculator's going to do the rest of the work for me. About 19.7. We'll round to the 1 decimal place. Okay. You can do it therefore statement. Yeah, let's do it. Why not? Therefore, the perimeter is approximately 19.7 meters. All right. So that's our first composite shape. What about our second one? Okay. So this one, they say it's a window. Okay. It's a window. And this window, how do we create this shape here? We created it by sticking a semicircle on top of a rectangle. A semicircle on top of the rectangle. So you know what, since we just did perimeter, I'm going to find the perimeter first, and then I'll find the area. Okay. So once again, they didn't show us the markings, but this is a rectangle. Okay, this is a rectangle here. So this here is also going to be 150 centimeters. Okay, so this is 150, this is 240, this is 150. So you know, if I find this arc, if I found the length of this arc, I can tell you what the perimeter is. So how can I find the length of this arc? Oh, wait a minute, this is a semicircle. So what we're going to do is we're going to imagine there was a full circle and find the circumference of that circle and then divide by 2. Okay? Because the circumference of a semicircle is half of that of the full circle. So you know what? Let's try it out. So perimeter equals 150. I'm going to start from here. 150 plus 240 plus 150. And I'm going to say this one more time. Please don't add this. This measurement, which is 240 centimeters, please don't add that as a part of your perimeter calculation. That has nothing to do with your perimeter. Okay? So now, back on track, let's find the length of this arc, which is half of the circumference. So you know what? I'm going to find the circumference, which is pi d. You can look at your formula sheet, but the formula for the circumference of a circle is pi times the diameter. The diameter is 240. Wait a minute. This is pi times diameter. That's a full circle. That's a circumference of a full circle, but I don't have a full circle. I have a semicircle. So I'm going to take this and divide it by 2. I'm going to let the calculator do all the work. $916.99, about 917.0. Okay, so that was perimeter. What about area? How do you find the area of this composite shape? So you know what I'm going to do? I already cut the figure, the composite shape. I am going to label this as 1 and 2. So 1 is my semicircle and 2 is my rectangle. So I've identified my basic shapes. So if I find the area of the semicircle and I find the area of my rectangle and I add them together, guess what? I have the area of my composite shape. So let's write that down. The area of the composite shape is equal to the area of the first figure, which is our semicircle, plus the area of our second shape, the rectangle. So, what's the area of our semicircle? Well, what's the formula for the area of a circle? Pi r squared. Pi, what's the radius of this semicircle? Well, the diameter is 240, so the radius is 120. Okay, because diameter is double that of radius. Or you could say radius is half of the diameter. Now don't forget, this is for the whole circle, but I don't have a whole circle. I have a semicircle. So this is pi r squared, and we'll divide it by 2. So this is the area of my semicircle. Plus, what's my second shape that makes up this composite figure? The rectangle. Look at the formula sheet. The formula sheet says that the area of a rectangle is length times width. So 150 times 240. Punch out in your calculator, and then we're good. So we're looking at, whoa, this is huge, 58,619.5 square centimeters. This is a pretty big window. I'm just checking the calculations because this is a very big number. Is that a reasonable value? Yeah, seems reasonable because 120 squared is pretty big. And then multiply by pi. And 150 by 240 itself is already a very big number. 150 by 240 is already 36,000. Yep. Yep, the answer seems reasonable. Okay, so we could do it therefore statement. Therefore, the perimeter is approximately 917 centimeters, and area is approximately 58,619.5 square centimeters. Okay, one more composite shape to go. So we have a composite shape, and we're asked to find the area. So you know what? I'm going to do the exact same thing as last time. I'm going to cut up this composite shape. I'm going to cut the composite shape such that I know how I made it using my basic shapes. So I'll call this 1, 2, 3. So luckily, I can actually tell you the area of this rectangle, what I've labeled as number 2, because rectangle's formula for area is length times width, which I have both. And shape number 3 is a square. I also have sufficient information to find the area of shape number 3. What I don't know is how to find the area of shape number 1, because this is a triangle. I need base times height divided by 2. I don't have the base. I don't have the base. And once again, we forgot the marking here, but this is a right angle. Okay. So if that is a right angle, guess what? I can use the Pythagorean theorem. So I'm going to call this x. So x squared plus 3 squared equals 5 squared. Okay, let's do the math. X squared plus 9 equals 25. Subtract both sides by 9. You get 16. Square root both sides. 4. X is 4. So you know what? Now that I know what x is equal to, I can solve for the area of this composite shape. So let's write this down. The area of the composite shape is the area of the first figure, which is a triangle, plus the area of the second figure, which is a rectangle, plus the area of the third figure, which is a square. If you don't know the formulas, use the formula sheet. Okay, so base times height divided by 2. So since I know x, which is the base, is 4, and the height is 3, I can tell you the area of the triangle. What about the rectangle? Length times width, 3 times 15. And the last figure is a square. That's just the side squared, which is side length is 4 for this square. Okay, this is 6. 6 plus 45 plus 16. 67. Oh, we don't have the units. It's just square units. All right, let me just triple check this calculation. 4 times 3 is 12. 12 divided by 2 is 6. This is 45, 16. Yep, sounds reasonable. All right. So this is truly, this lesson here is truly an extension of what we did earlier. So we first talked about the idea of area and perimeter. Then we introduced our basic shapes just to refresh our memory from elementary school. And once you get comfortable with the basic shapes, we stick them together and make composite shapes. But the goal is still the same. Even though we're making composite shapes, the goal is still to find the area and find the perimeter.